All right, we are live. This is what we're looking at. PCB. Figured out how to do a 3D model of this. It's the 3D button, as one might expect. Um, Managed to get a good thumbnail photo from this guy. So excited, excited. It's exciting stuff, exciting stuff. But here, I'll close out of this. It's actually not useful in the slightest for us electrical guys. Or forgot to fill up my water, but anyway, let's get back to it. So uh, pretty much where I was at last time was thinking, all right, we want to get sort of the high-speed data lines done, namely the USB lines. Those are the really tricky ones. And from there, we sort of take a Manhattan routing approach to the rest of the GPIO interrupt lines, as well as pretty much doing the power planes, keeping them on layers 1 and 2, the inner layers. So let's take a look at the inner layers first. When you're looking at the inner layers, what you'll see is that, yeah, it's pretty much the ground plane plus some power planes, maybe a GPIO here and there, but here, maybe we can get rid of the components as well. So pretty much we're pretty limited on what we want to do on the inner layers. Like for this one, it's mainly power here, which is the VDD3P3, I suppose. I think that's what that says. Yeah, VDD3P3. As well as a couple other planes here, but yeah, for the most part, we're going to be trying to route. Yeah, same story for inner layer 2. It's mostly just ground, trying to connect all these different ground vias together, as well as this VDD mod. So that's for the modem. This is a big heavy hitter of current. That's probably the most current consumption we're gonna get. Oh, by the way, let's make sure the stream's okay. Select stream. Select stream. No current live streams. Hmm. Yeah, I want this one. Okay. Okay. Yeah, I think we're fine. I think we're fine. Um. Yeah. Yeah. Still getting used to this. Still getting used to this whole thing. Anyway, yeah, we want to constrain our routing to bottom and top when it comes to these GPIOs. And yeah, I think at this point we just got to make sure that we've routed all the differential layers. I also want to see if I can optimize this. I'm not really satisfied with how I routed this. So if we include the bottom side and get rid of the copper poor regions, see what I was trying to do. I was trying to make it symmetric where it comes up and around here this way for the minus. The reason why these are shorted is for USB-C to be able to plug in either way. The pads are different either way that it connects. So the way that you resolve that in terms of trying to get the signal back to the IC is pretty much through shorting these pads together in the connector. Honestly, now I'm thinking of just doing diff pair routing between this D plus, or maybe even this D minus and D plus, and then just, that's not going to work either because the routes are going to come up. No, it's pretty much going to have to be the outermost D minus, D plus. And that way we can get maybe this one coming in that way and then this one coming in that way. So let's try and go ahead and do that. So the outer ones is going to be B7 and B6. So if we go here, we're going to try to just isolate them. B7, B6. We're going to delete these net connections. Also delete these. Delete all this. Just try to go for the outer. Oh, don't want to cancel. Don't want to kill the connector. Get rid of these vias. Get rid of this net. I really wish there was a better way to select things instead of having to click over here between layers. So yeah. So we're pretty much gonna have this come out here and this come out here. So if we go to, where was it? There was a dialog box for the differential pairs. Okay. So this is modem USB D minus D plus. Thing is that these are associated with nets, and it seems like the nets are still associated with each other, and it wants to associate B6 with A6, but really it should be B6 with B7. That should be the actual that should actually be the association we want. So if I go here, if I do this, what's going to be this net name? Nothing, right? Yeah, that's what I figured. Do I have to push this? Is that why this isn't? Yeah, B6, B7. Why isn't this updating? Okay. Tools. Export. Design. Import changes from PCB. Maybe I need to import changes here. Import changes from schematic. Yeah, so that's what we want. Now if we do Alt D for this guy, yes, this is what we're looking for. Okay, I think we're in business. So, yeah, let's reconnect to this guy. So this was connected here. This was connected here. We'll do this. I think it was in design. Update, convert schematic to PCB. Now we have these connections back online. And if we do the diff pair, they are swapped. Boo-hoo. Lame. So, how do we resolve this? I think we just delete these and just do the simple way of just, swapping these guys. Okay. Okay, so now if we do this, look at that. Look at that. So if we bring these up a little bit, then we're gonna get the nice sort of thing there. Not super nice, honestly. If we bring it up a little more, Maybe it gets nicer. Not really. Honestly, the one where it goes straight up to it might be the best. That gives us options for this guy, for these guys. So if these go here and here, and now we save and we convert, update, apply changes. Now we can get this guy to come up here. Oh, is it because these are too wide? Is that why? Yeah, we want these to be 0.2. I think that's why we're getting issues. No, not 0.23. Yeah, because these don't want to be very large. So hopefully the differential pair associations are, no, it got fucked. Yeah, it didn't work. Okay, let's delete these again. Move on. I think it's Alt-I. Alt-I is the shortcut to update. Okay. Alt-D. Let's do this again. Yeah, that's what we want. That's better. That's so much better. Honestly, this needs to move in 1. Right? Or am I tripping? That doesn't seem right. I just think honestly, it could be that the grid routing, the grid might be bad. Well, it's not bad, but it's just non-ideal. Because you see little differences in how these come in, right? Like this comes into the corner, this doesn't, but it's not a big deal. It's not a big deal. So, yeah, that was more what I was expecting the shape of this to look like. So now we can save this, come over here, reconnect these. We'll make sure that these pinouts are correct, but in the meantime, we'll just push the changes. We will route D plus to D plus, not that way. I want to come this way. No. And then I want you to come back in here. That's fine. And then let's bring you out over here. And then we'll touch you in here. Why is this not perfect? I think this is a better solution than what we had before. We don't have any vias. The stubs are a lot shorter. I think this is going to work out a lot better. So it's good news, I think. I think it's great news. Yeah, okay. I think the only difference is that now this leg is shorter than this leg. Like you see here, this one only has to come out here and go up, whereas this one needs to go around and then through this whole thing in order to get up here. But I think at the end of the day, that's going to be compensated by these guys. Oh, you gotta be kidding me. Are these swapped? Are these swapped? No. Where's modem USB D plus going? Yeah, it's going to here, pin 9. Pin 9, yeah. So it's D minus. So D plus is going to pin 9. that's the case, then yeah, these are just permanently swapped. Maybe if that's the case, then we can. But this is on the. No, we can swap these. We can swap these because on the outside it's going to be longer than on the inside trace, right? And we're going to have to swap these. Oh, but that would really suck. It's going to really suck if we have to swap them. Yeah, because then that means D plus. So this is D plus, right? D plus now has to come in. These have to swap in order to go from this guy to being on the outside to hit here and then hit here. There has to be a better way. I really don't want to swap this. Here, let me grab some water. I'll be right back. All right, I'm back. So, what we're running into is that this wants to be swapped. They want to swap. So, all right. All right, how can we do this? Like, where are these diff pairs? Are these diff pairs? These are diff pairs. Where are they going? Can we just reorient this thing? Like, I don't see that much. Would that even help? So if I want D plus on the on the inside, no, it's gonna have to be on the other layer. We have to be, and that's impossible. Okay, so reorienting is not gonna help. Okay, can we come out this way? Yeah, so if we come out this way, where D plus D minus comes out, and then, yeah, if we snake around this way, that's going to be the only way that this comes out on top here. Is if we come out down instead of going up. It's going to be a shame. I'm going to have to disconnect these just to give myself some space, and then these are going to have to be like over here somewhere. So let's just go ahead and do that. I think it's better to do this than to introduce vias on USB lines, because this is USB-C and it's supposed to be fast, right? So yeah, let's delete all this. Let's move this out of the way. Yeah, we're gonna have to delete this, unfortunately. And these are gonna have to come out over here. And we're gonna have to come over here. We're gonna save. Delete these stubs again. Alt-I to push. Apply changes. I can't enter that. It's dumb. All right, Alt-D. Coming from here. Oh, so this thing can't even... If it comes out down... Alright, alright, alright. We'll be able to do this. So if I do this, then this, then this, then this, and then this, and then this. Yeah, so... That means that the intrapair skew is bad. Yeah, we're gonna have to put in some meanders for this. I was having trouble with this last time. I don't really know how to do this. Easy EDA intrapair skew or meanders. Differential pair routing. I want to look at... Oh, here we go. Equal length tuning. Okay. Click tab to bring up the equal length tuning. Line 40, set the... Yeah, okay. Man, I have no idea. So let's just give this like a old college try. Eh? Let's if we just do this, right? And then let's say we just bend over and we just have a long stretch. Okay? And this one's obviously going to be the greater one, so we want the meanders here. So equal length tuning. This one to that one. Please select the starting point for this. I want the starting point to be here. Oh, look at that. All right, and if we do this, let's do arc 90 degrees. Let's do single side. Gap width, I don't know. Oh, look at this. Look at this. Okay. I think I'm getting it. Okay, Shift A. Bam. Bam. Okay. Alt D. Alt D is nuts. Okay. All right, so now we know how to do that. That's pretty slick. Pretty slick. So this needs to... These need to swap. Okay, so we're gonna leave that for later. I'm gonna leave that to the end once we're done actually routing. So if we go Alt D to here, no, I want to go here. I want to go here. I want to go here. And then I want to go here. So I want these actually to be a little further out. I don't want this doing that. Okay, let's try this again. Alt D here. Let's come out a little bit like this. Yeah. Okay. Okay, that looks better. This is going to be deleted here, and then we are going to make these vertical. Come in off to here. Okay. Go here. Just straight shot them. And then from here, these can hit here. All right. Okay, and I think from there, I think it was Alt A. No, what was it? Shift A? Yeah. Here. No. I want it to be here. Is it this guy that's shorter? Okay, so it's this guy that's shorter. Let's give a meander there. Let's give another meander here. I don't like the way that. I don't really like how these look. Shift A, tab. Minimum amplitude, gap. So here we can bring this down. We don't need it to be that big. Here, let's do like 0.254 for now. Just make it the same. So if we do it now, yeah, we can have something like this. We can have something like that. I think that's fine. We might want to make this bigger, honestly. Honestly, this looks pretty tight. So let's do that. Control Z, Shift A, tab. We'll make this 0.508, 2 times a 10. So if we start here, we'll do one more here. Actually, we'll do it here. That looks better. Okay. Yeah, that's fine. Okay. So that's our diff pair. All right, let's check out the stream. How's it doing? Looks like we're still streaming. Good. All right, let's go back. What is this? What is this? Why is there a DRC? It's no bueno. Okay. So that is that. Just saved. So let's all right. What else do we need to do? Modem TXD, RXD. I I need to look at the data sheet. I don't know if this is a diff pair. Like, I don't need to put that much effort into it if it's not, right? So let's look it up. Vendor specs, Quectel, hardware design. All right, what are these pins? Main pin 34. Main UART receive, main UART transmit. Yeah, these are single-ended. UART receive transmit. Yeah, along with these are single-ended. Yeah, this is single-ended. So yeah, let's route them as single-ended. I'm honestly not that concerned about these guys. Yeah, it's mainly the USB lines that I'm concerned about. Did we do the yeah, we need to do these. We need to fix these up as well. So let's do that now. Where is it? Here. All right, Shift I to push. Is it Shift I or Alt I? It was Alt I. Alt I. All right, and this should be simple enough. We just wire this guy to this guy. Dude, just go in. Okay. Why is it so funky? Why is it so funky? Okay, here, minimum. Bam. Come in. There we go. Okay. Here. We're gonna try to keep it like this. That's fine. Okay. That's fine. That's fine. Okay. That is that for now. So that is how we're going to route the USB-C lines. So like I didn't even take into account like impedance, if this is impedance matched at all. Like I don't really know. I'm not concerned about that right now. Could go to like online calculators to try to keep it around 90 to 100 ohms differential, but this looks fine. This looks fine. I think it's gonna be better than what was there before. Like this looks pretty good. Yeah. Yeah. Okay. All right. All right. So that is that. So now I think those are the two main lines that I care about. This guy and this guy, the USB lines. Let me, what is this? let's make sure that the ESP32, this is not supposed to be differential. All right, what are a 36, 37? Where's the, oh, this is the pin list. What? VDD? That doesn't make any sense. Doesn't make any sense. Ah, this isn't it. I think this is the, I think this is the actual chip. What we have is a sort of the, what's it called? The little SIP, the system in package. So I wonder if the pins are different. Let's look at this guy. This might be what we need. Yeah, this is what we're thinking of using. Put in some Wi-Fi with that integrated antenna. Kind of neat, kind of neat. All right, this is what I care about. 36, 37. Yeah, these are just IOs. VSP IWP. What? I think these are just GPIOs. I don't think it doesn't matter that much. Okay, now we're gonna see if CAN is differential. Is CAN differential? Yeah, so this is differential. Yeah, okay, so this we need to route differentially. I wonder. Yeah, we can just introduce some randers here, just to make it a little better. So these are differential. These are routed quite poorly then. Yeah. Okay. Yeah, I want to create a differential pair. Come on, come on. Alt D. Okay. Design, differential pair manager. Where is this? Is that these guys? Yeah, that's those guys. Okay, we need to add these. All right, let's go ahead and do that. Okay, design, differential pair manager. I want to add DP CAN positive net, CAN high, negative net, CAN low. There we go. Apply, confirm. Alt D, bam, and yeah, that's so bad. Could probably just route it this way. Skirt along the edge here. Something like that, and then we can scoot this down maybe. I don't want to fuck this up. What's going on here? But I really want to move this up like one. I think we can do it. Yeah, I'm just gonna go for it. It's just gonna be better to hit with these guys. These can just move, I think. But these aren't even routed, I don't think. So I'm just gonna delete this, go from here to here. What's the width of this? 0.6. All right, let's do this. 0.6. Okay. There we go. Okay. That's pretty much that. That's pretty much that. This can not be there. This cannot be there. We can redo this. Super okay. More than okay to just reroute this to here. No, I don't want you doing that. Why are you going so far out? I messed up. Okay, Alt W. Go out there, go out there. 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 Okay, done. Okay. Now this should be better. Just a little bit, you know? Okay, so now I believe we can move this down here and move this down here. Just like that. Okay, that looks pretty good. So we're gonna probably need to put in some meanders, and unfortunately it doesn't seem like we have the space there. Maybe we can put one here. And that looks like it might just be enough. If we can put one there, let's put it here, right? Yeah. Just put it there. Okay. That's routed. Okay. I think we're doing good. Let's check out the stream. I think we're doing good. All right. Okay. Okay, I think those are the main ones that I was worried about. Why is VREF not tied? That probably needs to be tied to something. Here, let's see. This is differential, but I'm pretty sure we did that. We did these. Yeah, that's pretty much it. Okay, I think we're good. Oh, what is this? Yeah, I don't think this is differential. I don't think that's differential. Okay. So we're mostly done. We're pretty much done with differential routing. So now we have to decide. I think the top layer should be vertical. Maybe. Because look at this. It's sort of vertical, but there's nothing going this way. Doesn't matter. Here there's not going to be too much that wants to go here. It's gonna kind of suck. But yeah, I think maybe this layer should be horizontal. Yeah, if we look at everything here, yeah, there's so much stuff. All right, yeah, let's start routing such that top layer is horizontal. It's just not much space, but yeah, let's do top layer horizontal and bottom layer vertical. Okay. Oh, we also need to place these freaking components. Okay. Okay, where are these components going? What is this? I don't need this via. Keep on trying to slouch, but it's not good for me. Turn on the light. Okay. There's just so much junk here. And I need to place these things. Okay, this wants to be here. What is this? This wants to be here. Let's get rid of this via. Now where do you want to be? Is there something on the bottom? Yeah, let's get rid of this too. Yeah, at this point, I just want to try to figure out if we can do something kind of optimally, like re-optimize the placement of some of these components. I know it's sort of a tall task, but like for instance, where is this capacitor going? Where is this capacitor going? What is this? I think it'd be better if I had like silk screen. No. Solder mask. Yeah, I think this will be good. Thing is that I can't tell where these peripherals are going. I think I need to see the ref des. Okay, Q6. Where's Q6? Where's Q6? Oh, I'm gonna have to search. Oh, here we go. Q6. Okay. All right, these are diodes, and it's just okay. Okay, Q6 with the diode. You can do this. Right, and then R67 comes up like this, maybe like this, something, I don't know. Where's it going? So this is going to be tied to VDD mod. So that's going to be a plane that we could just tie into, so I'm not too concerned about that. It's really the status. Where's that coming from? Status is coming from here. So this is going to want to be in this area. So let's place it around there. It's actually like a pretty decent spot for this because there's nothing going on here. Okay. Is it okay, like that? And then this guy can be like here or something. Something like that. This guy could be here. I'm not too concerned about silk screen right now. That's sort of the least of my concerns. Yeah, so that's how we're gonna do this. Power's gonna come around over here. Let's I want to make sure that, no, this is, you sort of want a solid ground underneath, even a diff pair. Okay, let's look at inner one. Is there anything going on here? Layer, okay, inner one. That's what I want to see. I want to see inner one. Yeah. Oh, this is so terrible. This is so terrible. Look. This wants to come in right through here. Why is VDD mod coming in through here? I want to change it so that it doesn't come through here. So that way, like, this area has solid ground plane below it. Below the diff pair. You don't want to be contributing discontinuities like that. I'll worry about it later, but suffice to say, I think we do have a path at least going from, because, you know, ground is going to be pretty well connected on 16, right? You're going to have vias here. And VDD mod's going to just come around the bottom, I think, if we needed to. Yeah, just take up this whole corner and then hit these vias. So I'm not too concerned about that. All right, I think this is a fine spot for it. Let's refilter it. All right, I want to see the silk screen. I want to know what these components are. All right, C25. What is this? I wish it just highlighted it or zoomed into it if I select it. I'm trying to cross-reference here, you know? C25, is it a... I'm gonna have to search it. How is C25 picking up a switch? That's mind-boggling. What is going on? C25. Find all. Symbol. Find all. ID. What? Designate. I want to filter designator. Okay. So this is just a bypass cap for the modem. C25, C26. So it's just going to want to be here. It's going to want to be right next to here. So we're going to oblige and just put it here. I'm going to delete this. Don't need it. C25, and where's C26? Where's C26? Why? What? Control F. C26. Designator, C26. Why is it over here? Why is it over here? What? It's for VBAT RF. Alright, this needs to move. This needs to be here. I think the best way to do this is to actually have them like this and just have them have the plane come out from underneath here, tie into this, and then they just come back down into here, via down into ground. think that's the best way to do it. I don't think we have enough space. I'd be uncomfortable putting it that close. What is this? What is this? Why did YouTube give me this notification? What? 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 Why? Okay. Did I just get a virus? Is that what happened? Is that what happened? Did I just get a virus? God, have mercy on me. Okay, okay. If I found this cap all the way over here, then sort of cast doubt onto the rest of everything, right? Like that's a real simple mistake. All right, let's make sure that these caps are in the right spot. C30, C23, C24. C30. C30. Where's C30? Okay, where is this going? Ground. I know that, but where? Why did YouTube recommend that video? What? Okay, 32, 33. Where are those pins? Oh, you gotta be kidding me. So I didn't even put them next to the right pins. Where are these pins? 53, 52. 52, 53. These are up here. Such a doofus. Such a doofus. Why is this cap inside the SIM card area? Isn't this a component? This needs to be moved. This needs to be moved. Okay. We need caps here. We need to put caps there, so I think this shit has to move in order for this to move up so we can, I mean, thing is that this is so big. Look at this. Look at this. Maybe it doesn't need to be right there. Maybe you can put it over here. Then we screw up this this routing. Is that the worst thing in the world? Is that the worst thing in the world? Could put it vertical here. Can put it around here. What is this? We could put it here. I don't even. JP2? What is JP2? Antenna connector. Where's this GNSS coming from? Right there. Yeah, this wants to be right here. Honestly, why is it rotated like this? Why isn't it like this? Where it does this, and then you don't have to use a via. Get rid of this, and you just come over here. And then you deal with the other one. Why wouldn't you do that? So now the 3D view might be useful. I don't understand what's going on here. Like, why wouldn't you just want to do this? Just... I'm confused. I'm just going to change it and do that like this. That's so important. You want that to be as smooth as possible. This is an RF connection, right? You don't want to be screwing around with that. Where's this even going? Here? Comes around this way. Like here you could just sneak it in through here, right? It's not, doesn't need to come out that way. Yeah. Yeah. I'm concerned that I'm gonna have to move all this. It's gonna really suck. Like, this is gonna really suck to move. But I just don't have space for this capacitor. And it needs to be close. Like, you can't be having this capacitor be far away. It's not wise. It's not wise. And honestly, it could come up, like, it could squeeze in here, probably. Yeah, they would have to move all this. Oh, what an endeavor. What an endeavor. That's the thing, is that, like you can't tell me that you placed a component here knowing what you're doing, you know? Like, without a, you know, like, that's haphazard. Does this antenna need to be on the inside or on the is it, yeah, it's coming out on the outside. I don't know if that's what he wanted. Probably is. Yeah, there's like nothing on this side. Why didn't he want to place anything on that side? Don't really know. Don't really know. This is really cool. I like this 3D view. It's pretty neat. Pretty nifty, if you ask me. Um, Starting to enjoy it, actually. Like, it's easier to see what the pads are and like the components. I don't usually look at 3D views, but I do like how this is just so easy to look at and get to. So I'm enjoying it. I guess that's why it's called Easy EDA. I mean, am I right? Am I right? Um, yeah. I don't know why you wouldn't just connect it straight on like that. Like, why wouldn't you? Yeah, I think all of this has to go over here. I need to move this up. I mean, not all of it has to go over there, but like this has to go over there. And these have to scrunch in, and these have to move up. And this has to go up with it, and that'll give me the space for my caps here. And that's what I'm going to do. Okay. All right, let's delete all these routes. It's a shame. They were very nice routes. They were very nice routes, but it's a shame because these have to move. Sorry it has to be this way. I'm sorry, but that's life. Sometimes you just get deleted, you know? It's the life for traces and layout. It's just sometimes not optimal. And we are about optimality here in this establishment. Come on. Optimality is our middle name. Okay. I'm just going to move this over here. I'm going to move this up. I'm going to move this up as well. Not even sure where these want to go. They're even in the right spot, right? That's the thing, is that like I don't even know if they're in an ideal spot, if they're in a well thought out spot, because obviously these capacitors weren't, right? So who knows? Who knows? Okay, this is moving up. Still not quite enough space. All right, that looks fine. But there is going to be enough space up here, but it's just a shame it was all routed, you know? And I have to just delete it because I'm a meanie. A super big meanie. All right, where's C23? I want designator. I want to look at what's... Find all. C23. Bam. Okay, this was in a pretty decent spot. I don't know why it was connected to pin 56. Right? Yeah, C23. Am I looking at the right? Oh, God. C23 should not be connected to 54. C23 should be going to pin 32. Down here. So it's really C25, C26, C25, C26. These guys need to be next to 52, 53. Oh, so I was mistaken. I was mistaken. This does not need to be here. It's these two guys need to be there. So that means we can move this all the way back down. We can undo everything that we did. Unfortunately, we can't go any further. But even so, it's not going to fit. So it was necessary in the end. Hate to break it to you. Yeah, I hate to break it to you, but it was still necessary. This needs to move up. Why are there these random ground views everywhere? Don't get it. It's like this is... Okay. Okay, this is better. This is better. This needs to be here. As well as this guy. That is fine. Okay. Yeah, like I don't know why that route was there. Okay, that's routed. So these two are fine. Now it's these three that need to be down here in this corner. Fortunately, we do have the space. I'm gonna be putting this guy here. Actually, I'm gonna put it further out. And C23 and C24 are gonna be like this. They're going to be right up against each other. So that way they all have a good spot in order to come in. Okay, that's that. Placement is done for that. Let's check out. Yeah, I think now we just have to focus on placement because at least for these caps, let's focus on that now. Didn't realize that it was this bad. These are GPIOs coming in, so they don't have to be close. Honestly, like this doesn't have to be that close to this. We could just find a good open spot for it, but it's honestly pretty hard to come by. So yeah, let's find the caps that need to be close to things. Okay, we'll start from the top left and work our way across the pages. Let's yeah, it's 8:45, so I got only 15 minutes left. Okay. All right, so for the ESP32, let's make sure that C33 and C2 are in the correct spot. C33 and C2? No, this is R. C33, what? Oh, so it's only C2? We only have one. This is actually super confusing. I totally thought both of those were there. We're supposed to be there. Just fixing up the schematic because just it's not right when it's not easy to follow. All right. C2, that's the main one that we care about. Where is it? C2, find all. Nowhere close. Okay, C2. What? I need to stop leaning back like that. Alright, what? That was pin 2. It needs to be close to pin 2. That's not pin 2. Pin 2 is over here. That means it wants to be tucked away like right here. So I'm going to get rid of this. This capacitor can sort of be anywhere. This is going to want to be like right here. Yeah, we're going to delete this net. I'm going to place this guy right there. You see, this is sort of why we have to prioritize this, right? Is that, like, there was so much stuff here before that this would have been impossible to route unless we cleaned it up, cleaned this area up. And now we can, you know, try to find the space around it. Because that's... Why is this so far? Okay. Um, okay. Am I happy with this placement? I think so. I think so. This is just a pull up, right? Is this for an LED? Where's this going? ESP32 LED. Is that here? Yeah, this could literally be anywhere. This doesn't have to be here. I'm actually going to be moving this. R66, right? I'm not tripping. R68. Where's R66? What? What is this doing here? Supposed to be some pull down to ground for the USB-C connector. What is it doing here? All right, this is gonna be right here. There, you see, optimized. Optimized the layout. Beautiful things. C33. I'm pretty sure that's supposed to be, yeah, it's here. R40 is supposed to be here. So this is going to the enable. Yeah, so this sort of does want to be close to here. It's not the end of the world if it's not that close though. Like I would want this capacitor to be closer to the power rail than this be closer to that. So I'm not too concerned. Yeah, that should be fine. Pull up can be anywhere. Maybe I can spin this around like this. Is that ever gonna work? Not, it doesn't look like it. No, I don't like that. This looks better. Maybe we can move this over a little bit. Gives this guy like a chance to come in. It doesn't really matter that much. Like if the trace is coming down here, then it's just gonna hit it. The thing that bothers me though is that the trace is probably okay. Where is this going? Where is this going? Who is driving this pin? ESP32 enable. What is going on? What? So it seems like this logic is driving this enable. This is so weird. I don't know what I'm looking at here. You know what? I think I'm gonna call it an end of the stream. I think we figured out that we made progress, right? Like pretty much the prior person's work. I'm not saying it was bad, right? It was more like a first pass of just putting down the main idea of where things need to be, but it's like the details need some improvement, right? Like the placement of these various caps. They're small enough, right? He was probably just looking at the rat lines, just trying to make sense of things. And so I'm not all that annoyed, but yeah, the placement needs adjustment, and so that's what we're going to be concerned about. I think from now on, we're not really like even the diff pairs. They could be rerouted. That's fine. Like the placement of various things needs attention. Like for instance, we could if we wanted more space in this area. We can move this out of the way, and the diff pair could come down and around here, and then just come out there, and then that way we have more space here. So this is not, this is in some prime real estate right here. Like it's just blocking the path for this, and I don't even know what this is for. Like debug, what is this debug component? The DBG. Where is this? Yeah, just some diode. Doesn't need to be there. Could literally be anywhere. So yeah, stuff like that, and it's fine. It's just part of the work, right? Just trying to optimize things to fit. Because look, it's just not it's not a spacious board. It's pretty jam packed. You got to think about it, right, in order to actually get things done the right way, right? Like you can't be having bypass caps all over. It's got to be close to the power pins. Can't be having differential routes not looking good, right? Like it's gotta work. All right, well that's pretty much it for now. I don't think there was anyone who joined the stream this time, but I think it's useful to have for the backlog, right? Uh, and yeah, we'll see you next time. Peace.